Imagine a world unlike our own, a planet suspended in the cosmos, forever presenting one face to its star. On this world, the sun never rises and never sets. For one half of the globe, it is eternally midday, a relentless scorching noon that has lasted for billions of years. For the other half, it is perpetual midnight, a frozen, star-dusted darkness that has never known the warmth of a dawn. This isn't just a flight of fancy from a science fiction story. This is a real phenomenon known as tidal locking. The very concept challenges our earthbound intuition. We are creatures of rhythm, of day and night, of the rising and setting sun that governs our sleep, our agriculture, and our history. On a tidally locked planet, these familiar cycles are gone. Instead, there are just two permanent states of being, the light side and the dark side. How does a planet become locked in this cosmic staring contest? The answer lies in a force we experience every day: gravity. Think about our own moon. We always see the same face, the familiar man in the moon. That's because our moon is tidally locked to Earth. This is no coincidence. It's the end result of a long, slow gravitational tug-of-war that has been playing out for billions of years. A young planet, freshly formed, is likely spinning rapidly. As it orbits its star, the star's immense gravity pulls on it. But this pull isn't perfectly even, creating a bulge that acts as a brake, gradually slowing the planet's rotation until its spin perfectly matches its orbit. This process is most common with planets that orbit very close to their stars, especially smaller stars called red dwarfs. Red dwarfs are the most numerous type of star in our Milky Way galaxy. Because they are cooler than our sun, a planet would need to orbit much closer to them to be warm enough for liquid water. At such a close distance, the star's gravitational pull is incredibly strong, and the process of tidal locking happens much more quickly. Let's step onto the surface of our tidally locked Earth. First, we visit the substellar point, the very center of the day side, where the sun hangs forever at its zenith. Here, the concept of weather as we know it would cease to exist. The temperatures would be staggering, far hotter than any desert on our own planet. The ground would be scorched, baked into a cracked and sterile landscape. Any water that ever existed here would have boiled away into the atmosphere long ago. The very air would be thin and dry, as most of the planet's water vapor would be driven away by the heat, migrating towards the colder regions. Now let's journey across the planet to the opposite pole, the very center of the night side. Here we find a world of profound and absolute cold. This hemisphere has not felt the direct warmth of its sun for billions of years. The temperature would plummet to hundreds of degrees below zero, cold enough to freeze not just water, but gases like carbon dioxide and nitrogen right out of the atmosphere. Any atmosphere that drifted over from the hot side would quickly condense and fall as exotic snow, perhaps nitrogen snow. This side of the planet would be a colossal cold trap, locking away the world's volatile elements in a deep freeze. Between the realm of fire and the realm of ice, there exists a place of compromise, a ring of eternal twilight that circles the globe, forever separating the day from the night. This region is called the Terminator Line, or the Twilight Zone. Here, the sun is always on the horizon. For some parts of this ring, it is a perpetual sunrise. For others, a perpetual sunset. This is where the extreme conditions of the two hemispheres begin to moderate. The light is gentle, the shadows are long, and most importantly, the temperature might be just right for liquid water to exist on the surface. The weather in this zone would be unlike anything on Earth. The vast temperature difference between the hot and cold sides would drive winds of incredible planet-spanning power. Hot air from the day side would constantly rise and flow towards the cold side at high altitudes, while cold, dense air from the night side would creep along the surface back towards the day side. This would create a permanent global wind system. This process could create vast networks of rivers and lakes along the Terminator, fed by melting glaciers from the edge of the night side's ice cap. It is here in this narrow, chaotic, and beautiful ring of twilight that the miracle of life could find its stage. Surviving on a tidally locked planet would be an immense undertaking, a testament to the resilience of any life form, including humans. The primary challenge, of course, is the extreme temperature gradient. We would not and could not live exposed on the surface. The most logical place to build would be underground or within the sheer cliff faces of canyons and mountains. Growing food would require moving agriculture indoors. Giant subterranean hydroponic and aeroponic farms would be the breadbaskets of these new worlds, lit by powerful, full-spectrum LEDs, powered by the planet's abundant energy. Energy would be abundant if we knew how to harness it. The day side of the planet would be a solar energy farm of unimaginable scale. We could deploy vast arrays of solar panels in the near dayside region. The constant, powerful winds would be another source of limitless energy. Huge, durable wind turbines, anchored deep within the rock of the Terminator Zone's mountain passes, could generate electricity all the time. Our civilization would likely be a long, thin ribbon of interconnected cities stretching around the planet. Travel between these cities would happen through underground maglev train systems. Life, wherever it exists, is a master of adaptation. On a tidally locked world, we would expect to see evolution produce some truly remarkable organisms. With sunlight always coming from the same low angle, plants might not grow straight up. On a world with such powerful winds, flight might be a common mode of transportation. We might see creatures that are expert gliders, with large wingspans designed to ride the permanent air currents, traveling effortlessly for thousands of miles along the Twilight Zone. Closer to the night side, we might find life that doesn't rely on photosynthesis at all. Perhaps there would be ecosystems based on chemosynthesis, drawing energy from chemical reactions in volcanic vents or mineral-rich water. This exploration isn't just theoretical. The universe has already shown us that these worlds are not only possible, but likely very common. A prime example is the TRAPPIST-1 system, located about 40 light-years away. Another fascinating example is Proxima Centauri b, the closest exoplanet to our solar system. It orbits Proxima Centauri, a red dwarf star, and is also considered a strong candidate for being tidally locked. The James Webb Space Telescope is one of our powerful tools for this job, capable of analyzing the starlight that passes through an exoplanet's atmosphere to tell us what it's made of. So, let's end where we began, with a question of feeling. What would it actually feel like to stand on the Terminator line of a tidally locked world? Close your eyes for a moment and imagine it. To one side, the sky is a permanent, beautiful gradient of sunset colors, reds, oranges, and purples that never fade. The sun, huge and red if orbiting a red dwarf, hangs motionless at the horizon, casting impossibly long shadows that have not moved in a million years. You would feel the wind, a constant, powerful presence flowing from the cold darkness at your back towards the dim light ahead. It would be the breath of the planet itself, a physical reminder of the colossal heat engine that drives this world. To the other side, the sky deepens into a profound and star-dusted darkness, a window into the infinite cosmos, unobscured by atmospheric glare. The constellations would never move. Future civilizations there might map the universe with a precision we can only dream of. This journey of the imagination reminds us that our earthly perspective is just one of countless possibilities. The universe is not obligated to conform to our expectations. It is wilder, stranger, and more wonderful than we can often conceive. Each new world we discover, whether it's a tidally locked planet, a gas giant with 100 moons, or a rogue planet wandering starless through the void, invites us to ask new questions. It encourages us to be curious, to keep exploring, and to marvel at the cosmic forces that shape these diverse and amazing places. The story of what's out there is the greatest adventure of all.